Om Swastiastu. My name is Samuel Benaya Batubara. In this occasions, I will explain about metal rolling process and equipment from chapter 13 from the book Manufacturing Engineering and Technology 6th edition. Rolling is the process of reducing thickness or changing the cross-section of a long workpiece using compressive forces applied through rotating rolls. It is the most widely used metal forming process, accounting for about 90% of all metal working operations. Rolling was first developed in the late 1500s, and today it is essential in the production of steel, aluminum, and many non-ferrous metals. Rolling may also be applied to non-metallic materials such as plastic, powdered metals, ceramic slurries, and hot glass. A wide variety of industrial products are made through rolling. Plates are used for ships, bridges, and machinery. Sheets are widely used for car bodies, aircraft structure, appliances, and containers. Foils are used for packaging, especially aluminum foil. Ship-rolled products include I-beams, railroad rails, and structural profiles. Rolling also produces wire, bar, tubes, seamless pipes, bolt, screw, and threaded components. Hot rolling is performed above the metal's recrystallization temperature. This process breaks down the coarse, brittle, and porous cast structure into a fine-grained rod structure with better ductility. Hot rolling, on the other hand, is performed at room temperature. It produces a higher quality surface, better dimensional accuracy, and higher strength due to strain hardening. However, hot rolling requires more energy because the metal is stronger at lower temperatures. Rolled products are classified mainly by thickness. Plates are thicker than 6 mm and are used for heavy-duty structures such as ships, boilers, and reactors. Sheets are less than 6 mm thick and are supplied in coils or flat sheets. They are essential in automotive and aerospace applications. Foil is extremely thin, often below 100 mm, and is commonly used for packaging material. In flat rolling, a strip metal enters the roll gap and is squeezed into a thinner thickness as the rolls rotate at constant speed. The entry velocity is lower than the exit velocity because the strip elongates as its thickness decreases. Along the arc contact, there is a neutral point where the strip surface speed matches the roll surface speed. Before this point, the roll moves faster than the strip, and after the neutral point, the strip moves faster than the rolls. This frictional interaction is what pulls the material into the roll gaps. The maximum possible reduction in thickness, called the draft, depends on friction and roll radius. The greater friction allows the rolls to grip the material more effectively. A large roll radius also increases the maximum draft because it increases the contact length. However, excessive friction is undesirable because it increases rolling force, power consumption, and can damage the surface. Therefore, lubricants are used to maintain controlled friction. Roll force is the product of the roll strip contact length, strip width, and the average true strength of the material in the roll gap. This force determines the torque required to drive the rolls. Rolling power depends on the force, the arc contact, and the rotational speed of the rolls. In general, harder materials, larger reduction, and larger roll diameters require significantly higher forces. To reduce roll forces, several strategies can be applied. First, we can reduce friction using lubricants. Second, using smaller diameter rolls decrease the contact area. Third, making smaller reduction per pass lower the load. Fourth, rolling at elevated temperature reduce material strength. Finally, applying front or back tension to the strip lowers the compressive load needed for deformation. During rolling, rolls elastically bend due to the large forces involved. This bending causes the strip to be thicker and at the center than at the edge, phenomenon called frown. To encounter this, rolls are ground with a sledgehammer, meaning the center diameter is intentionally larger. Heat generated during rolling may also cause thermal chamber, which must be controlled through cooling. In addition, spreading occurs when the material widens as it passes through the rolls, especially when the width to thickness ratio is small. Chatter is a harmful self-excited vibration that can occur in a rolling operation. It causes periodic thickness variation, poor surface finish, and can drastically reduce productivity. Chatter is influenced by rolling speed, lubrication, reduction per pass, roll radius, and the stiffness of the mill structure. Modern mills use sensor and feedback systems to detect and reduce chatter. In industrial practice, rolling usually begins with hot rolling to break down the cast structure. The product from hot rolling may be a bloom, billet, or slab. Before cold rolling, the surface scale formed during hot rolling must be removed by pickling, water blasting, or grinding. Cold rolling produces a better finish, tighter tolerance, and stronger material due to strain hardening. Aluminum foil is commonly produced by pack rolling, where two sheets are grouped together. After rolling, sheet metal may not be perfectly flat. Leveling rolls bend the sheet repeatedly in alternating direction to remove waves and improve flatness. Temper rolling, also known as skin pass rolling, gives a small reduction of about half to 1.5%. This eliminates yield point elongation and prevents the formation of loose bands during foaming operation. Rolled product may contain various defects. Wavy edge occur when the edge elongates more than the center due to roll bending. Zipper crack forms when the center of the strip fractures because of insufficient ductility. Edge crack occur when the material at the edge cannot withstand the deformation. Alligatoring is a rare but severe defect where the workpiece split lengthwise, resembling an alligator mouth. This defect can be minimized through proper material preparation and controlled rolling condition. Residual stresses form due to non-uniform deformation during rolling. Small diameter rolls or small reductions tend to deform the surface layer more than the center, creating compressive stresses on the surface. Large diameter rolls or large reductions deform the bulk more, producing tensile stress at the surface. Residual stress can affect dimensional stability and must be considered in subsequent forming or machining process. There are several types of rolling mills used in industry. Two-mite mills, two-high mills are simple and are often used for initial breakdown passes. Three-high mills allow reversing the direction of rolling without reversing the rolls. Four-high mills and cluster mills use small diameter work rolls supported by larger backup rolls, enabling high reduction and thin gauge. Tandem mills consist of a series mill that rolls the strip continuously through several stands, greatly increased productivity and precision. In tandem rolling, the strip passes through multiple stands in sequence, with each stand reducing the thickness further. This method allows high rolling speed and precise control of thickness. Computerized control system adjusts the speed, tension, and reduction in each stand to maintain consistent product quality. Rolls must be strong, wear-resistant, and capable of withstanding thermal stress. Common roll materials include cast iron, cast steel, forged steel, and tungsten carbide for small work rolls. Lubricants are used to control friction and temperature. Hot rolling of ferrous metal is usually done without lubricants, while non-ferrous hot rolling and cold rolling requires oil or emulsion. Shape rolling forms long structural products such as I-beams, channels, and rails. The workpiece passes through a series of shape rolls that gradually form the final profile. Designing roll faces require expertise to avoid defect, control dimension, and minimize roll wear. Roll forging or cross rolling use rolls with profile groove to shape round bars into tapered or contoured section. It is commonly used to produce shafts, leaf spring, knife, and preform for forging. This process improves grain flow and produces stronger components. Skew rolling is used primarily to produce spherical blanks for ball bearings. A round bar is fed between two skewed rolls, which form the spherical shape continuously. These blanks are later ground and polished to produce precision balls. In ring rolling, a thick ring is placed between two rolls, and as the thickness decreases, the diameter increases due to volume constancy. This process is used to manufacture large rings for turbines, jet engines, bearing, pipes, and aerospace components. Ring rolling provides material saving, excellent dimensional accuracy, and a favorable grain flow direction. Thread rolling is a cold forming process used to create thread on rods or bolts. It uses a flat or cylindrical die to displace material and form thread without cutting. Thread rolling produces stronger thread because the grain flow follows the thread contour, and it also provides a smooth surface finish. Most fasteners today are produced through thread rolling. Rotary tube piercing, or the management process, produce seamless tubes from solid round bars. Due to cyclic compressive stresses, stainless steel stress form at the center of the bar, creating a cavity. The bar is pulled through skewed rolls with a mandrel inside to enlarge the shape and shape the tube. High quality starting material is essential to prevent internal defect. Tube rolling reduces the diameter and thickness of tube using rolls with or without a mandrel. Filigree rolling is a common method in which the tube and mandrel reciprocate. White rolls shape the tube during rotation. This process produces tubes with precise dimension and excellent surface finish. Integrated mills are large facilities that melts iron ore, produce molten steel, cast into slabs or billets, and then roll into finished products. Mini mills, on the other hand, melt scrap metal using electric arc furnace and roll the metal into specific products such as bar or rods. Mini mills have lower captive costs, lower energy consumption, and serve local markets efficiently. To summarize, rolling is the most important metal forming process. It produces a wide range of products, from thick plates to thin foil and complex structural shapes. Rolling can be done hot or cold, and the choice affects the material's properties and surface quality. Various rolling mills can specialize process allow the production of tubes, ring, thread, and precision components. Understanding this process is essential for selecting the right manufacturing method for engineering application. The material for this presentation was fully adapted from Chapter 13 of Kalpakjian and Smith Manufacturing Process for Engineering Materials. And that is all for this video. Thank you for watching. Om Santi 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 Om.